Welcome students, we are expected to evaluate integral 0 to infinity x negative 1 over 1 positive x cube times dx. Now there are many ways to evaluate this integral, but I would be following a different approach. But eventually we will have to resort to the system of usual using partial fractions to bring about the solution. But to start off with, what I would like to do is I would like to rewrite 1 positive x cubed as 1 positive x cubed, positive x squared, negative x squared. So with this, the entire system can be easily simplified. So this can be rewritten as 1 positive between x cubed and x squared. I would like to take x squared out, and that would give me x positive 1 followed by a negative x squared. Now I would like to join 1 with negative x squared. So this is going to be x squared of x positive 1 followed by a positive sign and 1 negative x squared. Then I would like to rewrite 1 negative x squared as 1 negative x and 1 positive x. From here I can easily take out x positive 1. So that would mean I would now have x squared here followed by 1 negative x. So we can rewrite this as x positive 1 times x squared negative x positive 1. So this is all done for the denominator. Now from here onwards everything is simple. So therefore integral x negative 1 divided by 1 positive x cubed times dx, limit 0 to infinity, is rewritten as x negative 1 divided by this quantity x positive 1 times x squared negative x positive 1 times dx. Now what I will do is I will like to use partial fractions. So using partial fractions, so let us consider x negative 1 divided by x positive 1, of course the limits are 0 to infinity, times x squared negative x positive 1. So I'm going to write this as a over x positive 1 positive bx positive c divided by x squared negative x positive 1. So if we had to cross multiply, on the left it's going to be x negative 1, on the right it's going to be a times of x squared negative x positive 1 positive bx positive c times x positive 1. So foremost we can make the following substitution. What I would do is let x be equal to negative 1. On the left side it's going to be negative 1 negative 1. On the right hand side it's going to be negative 1 squared would give me, this is going to be negative of negative 1 positive, this is all going to vanish. This is going to be 0. So this is going to be a of 1 negative negative positive followed by positive 1, which is equal to 3 times of a. On the left hand side you get a negative 2. So therefore negative 2 is equal to 3 times a. So a is going to be negative 2 over 3. So this is the first value we have got. Next I would like to take x is equal to 0. If I place x is equal to 0, 0 negative 1 is equal to a times of 0 negative 0 positive 1. b will vanish, so c alone will be there. So c positive, 0 positive 1. So this will be positive c. This is going to be a is equal to negative 1. But the value of a is negative 2 over 3 positive c. Of course I got a negative 1. So bring this to the left hand side. So it's going to be negative 1 positive 2 over 3 is equal to c. So therefore c is equal to negative 3 positive 2 over 3, which is negative 1 over 3. So this is the value of c. Now I need to get the value for b. So what I will do, I've taken x is equal to negative 1. So now I will take, let x is equal to positive 1. If I were to take x is equal to positive 1, the left side, this one will vanish. So it's going to be 1 negative 1 0. So this is a of 1 negative 1 positive 1. X is equal to positive 1. That's the reason. Positive b times x is equal to 1 followed by c. 1 positive 1 is going to be 2. So positive 1 negative 1 gets cancelled. This is going to be a positive 2 times b positive 2 times c. but the value of A is negative 2 over 3 followed by 2 times B followed by 2 times C is negative 1 over 3. So this is going to be negative 2 over 3. This is going to be negative 2 over 3. And this is going to be positive 2 times B, which is equal to negative 4 over 3 positive 2 times B. And I push this to the other side. So let me use the space here. This is going to be 4 over 3 is equal to 2 times B. So therefore B is equal to 2 over 3. So I've got the value for A, I got the value for C, I got the value for B. So we will have to use all of this. So therefore integral 0 to infinity, we started with this x negative 1 divided by 1 positive x cubed times dx was rewritten as 0 to infinity a over x positive 1 positive bx positive c divided by x squared negative x positive 1 times the dx is now equal to integral 0 to infinity. The value of a is negative 2 over 3 divided by x positive 1. The value of b is 2 over 3 times x. The value of c is negative 1 over 3. So this divided by x squared negative x positive 1, and this has to be multiplied with dx. So I would rewrite this as negative 2 over 3 integral 0 to infinity dx divided by x positive 1 and 2 over 3 x and negative 1 over 3. I will take 1 over 3 out. So positive 1 over 3 out. So that is going to give me 2 times x negative 1 times the dx divided by x squared negative x positive 1. Now this is equal to negative 2 over 3 ln of x positive 1, ln of x positive 1. The limits are 0 to infinity. Okay, so this is going to be, now just consider this. Let me make the following substitution. So let me use the space here. Let x squared negative x positive 1 be equal to t. So this is 2 times x negative 1 times the dx is equal to dt. So this is actually dt divided by t, which is nothing but ln t, which is nothing but ln of x squared negative x positive 1, right? So we can place that here. So this is going to be 1 over 3 positive sign ln of x squared negative x positive 1. Of course the limits are there, 0 to infinity. Let me just use this part of the page. Okay, so let me rewrite what I have got. So this is equal to, I'm going to write this as the original question. So because we don't have space, I would like to write down the question, the last step again. So we got negative 2 over 3 of ln of x positive 1 raised positive 1. This has a limit from 0 to infinity, positive 1 over 3 ln of x squared negative x positive 1, limits are 0 to infinity. Now my idea is I would like to rewrite this first component as some constant times the second component. So only then we can simplify it, right? We have to solve it. So for that, what I wish to do is I would like to rewrite this as negative 1 over 3, and then I will take the 2 inside. So there's going to be 2 times of ln of x positive 1, limits are 0 to infinity, positive 1 over 3 ln of x squared negative x positive 1, limits are 0 to infinity. Now there is a formula. What is that? A times ln b is equal to ln b raised to the power of a. Now if I were to use this formula, this is equal to negative 1 over 3 ln of x positive 1 raised to the power of 2, limits are 0 to infinity, positive 1 over 3 ln of x squared negative x positive 1, limits are 0 to infinity. Now I can expand this, which is negative 1 over 3 ln of x squared positive 2 times x positive 1. The limits are 0 to infinity. Positive 1 over 3 of ln of x squared negative x positive 1. The limits are 0 to infinity. Now both of them have got 0 to infinity. So what I wish to do is I would like to rewrite it as negative 1 over 3 ln of x squared positive 2x positive 1 positive 1 over 3 ln of x squared negative x positive 1. The limits are 0 to infinity. I can very well write it like this. Now I need to make a slight flip, or I can just take 1 over 3 out. So if I were to take 1 over 3 out, this is going to be, I want to write the positive component first. So ln of x squared negative x positive 1 negative ln of x squared positive 2x positive 1. Limits are 0 to infinity. Now we know a formula. What is our ln a negative ln b is equal to ln of a over b. So by this is equal to 1 over 3 of ln of x squared negative x positive 1 divided by x squared positive 2x positive 1. The limits are 0 to infinity. Now before applying the limits, I would like to make the following changes. Okay, before we apply the limits. So what is the change I wish to do that? Now we know that we have got this one, 1 over 3 of limit of x squared negative x positive 1 divided by x squared positive 2x positive 1. The limits are 0 to infinity. So I would like to apply the upper limit. Now for applying the upper limit, I want to do the following changes. So I would like to take ln of x squared out. So this is going to be 1 negative 1 over x positive 1 over x squared divided by, I take the x squared out, is going to be 1 positive 2 over x positive 1 over x squared. Right? This is for applying the upper limit. So probably I can just place a parenthesis like this and apply infinity. Now followed by, I need to apply the lower limit. So ln of, I'm not doing any change, x squared negative x positive 1 divided by x squared positive 2x positive 1. So in this case the limits is 0. Of course there is the square block. Okay, so upper limit minus lower limit. Now x squared can be cancelled. Now in this case, as x is going towards infinity, 1 over x will go towards 0. So this is 0, this is 0, this is 0, this is 0. What we are left with? We are left with 1 over 3 times of ln 1. This is what we are left with. Now this is for the case of the upper limit. Now for the lower limit, just apply x is equal to 0 here. When x is equal to 0, this is 0, this is 0, I get what? I get ln 1 for this numerator. And what do I get here? 0, 0, I get ln 1. So this is what I get. So ultimately what we are arriving at? We are arriving at 1 over 3 times of 0, which is equal to 0. So that is the solution for this question. I know this is a little bit lengthier, but I need to make sure that all of the steps are extensively done. Thank you, students. Enjoy your day.